So when we talk about counting numbers, what we're trying to really talk about is counting numbers in what's called an arithmetic sequence. And an arithmetic sequence is a sequence with a common difference, meaning the difference between any two successive numbers is the same. The most basic kind of arithmetic sequence would be a sequence like this. 4, 5, 6, 7, 8. The common difference is 1. It's just basic counting. Now, when the question is, how many numbers are there from 4 to 8? Well, if you think about it, a very common method, you know, obviously everybody in here, everybody that's watching would probably just count it to begin with and see the answer is 5. But if the numbers were big, you may do this, 8 minus 4, and claim, well, wait a second, I got 4 numbers, because 8 minus 4 is 4, not 5. Well, what happens is, it turns out, whenever you subtract the last number from the first number, you're actually subtracting a distance, whereas each of the numbers represents a point. And so the distance then represents the gaps, because each number has got a distance of 1 between them. So when I say 8 minus 4, I'm saying I've got 4 gaps of 1. And so those 4 gaps don't tell us how many numbers, they tell us how many gaps there are. And it turns out that there's always one more number than there are gaps, and so the key is to add 1. Now, if the numbers are separated, like this is still an arithmetic sequence. The difference between each successive number is 3. When I do 16 minus 4 and get 12, that tells me, you know, how much distance is between 16 and 4. Each of my gaps has got a size 3, because that's the difference. 7 minus 4, then it's got a size 3. So the number of gaps equals 4. But again, you always have to add 1 more than the number of gaps. So whenever you're trying, your formula or your algorithm is the gaps plus 1. So you've got to count the number of gaps, or the number of spaces in between the numbers, and then add 1 to that. The way we do the formula a little bit more mathematically, instead of just using the word gaps, is we say the last number minus the first number divided by the difference, you know, whatever that common difference is, plus 1. So here it was 16 minus 4 divided by 3 plus 1, which gave us 5. And so that's how you count numbers in arithmetic sequences. It's all about counting gaps and then always adding 1. So when I look at number 10, it says how many integers are there from 18 to 91 inclusive? Where an integer is just a counting number, and so the difference is 1. So we just do our formula. The last number, 91, minus the first number, 18, divided by 1, because since they're just integers, their difference is a common 1, so we don't really even have to divide by 1. And then at the end, we always add 1, because that gives us the number of gaps. So this is going to give me 73 plus 1, which is 74. So there are 74 integers from 18 to 91. Another way to think about it is to actually move your numbers to start with 1, which means to subtract 17 from 18 to get 1. And if you subtract 17 to 18, you can also subtract it from 91, and that would give you 74 as well. That's not as reliable a method to do these problems. All right, 11, how many integers are there in the following sequence? It is arithmetic because there's a difference of 4, right? 7 minus 3 is 4, 11 minus 7 is 4, 15 minus 11 is 4, so you have all these 4s here. So you do last minus the first, 83 minus 3 divided by the difference, which is 4, plus 1 equals, well, 80 over 4 plus 1, which equals 20, plus 1, or 21. So the correct answer to that problem, the number of integers, is 21. Mark starts at 242 and begins counting down by 5s. And so what he does is he creates an arithmetic sequence, except that it's going backwards, but that doesn't matter. And we just keep counting down by 5. And you want to find out how many numbers does he actually count. Well, it tells you nicely what the last number is, so you could apply the formula. The formula is, and again on this one, we want you by the first minus the last works if you're going to do, if you do negative numbers, because technically the difference here would be -5 instead of +5. It doesn't matter. It's probably easiest just to do the biggest minus the smallest. So it's probably easier just to, in this case, to do 242 minus 77 divided by 5. If you did 77 minus 242, then you divide by -5. But I know not everybody is comfortable with negative numbers yet. So just do it 242 minus 77 divided by 5 and then add 1. So that's going to give me 165 divided by 5 plus 1. 165 divided by 5 is 33. 33 plus 1 is 34. And that is how many numbers Mark counted starting at 242 and counting down by 5s.